I'm ESA astronaut Frank De Winne, and I'm here on board of the International Space Station in our fabulous Columbus module, our European lab here on board of the ISS. I know that you are also going to do a lot of experiments and science activities and educational activities focused around human spaceflight. And also that you're going to do a lot of hands-on activities. Have fun with it. It's by doing hands-on activities that you learn a lot. Here in the ISS we also do a lot of space science in microgravity. As you can see, I can be floating around here. That's all what microgravity is about. We can also have fun, like twisting around or making a looping. That you can't do on Earth. Look at this. If that isn't fun. But let me show one of the experiments that I have prepared for you. As like everywhere, you need to have a little bit of setup for an experiment. So I have here a water bag, because the experiment I actually gonna do with water. Water is very important for us, for all the life actually that is on Earth, and especially for humans, but also for us here on board of the space station. But it has also some very peculiar properties. For example, water is built out of oxygen and hydrogen. Now they are built in such a way that the oxygen is on one side and the two hydrogen atoms are on the other side. And since the hydrogen is positive and the oxygen negative, this forms what we call a dipole. Positively charged on one side, negatively on the other side. And we can demonstrate this in orbit. Look, I'm making a nice bubble out of this drinking bag. We have to be careful on space with water, because water is of course, it will float everywhere around, and with all the electricity around here, it could be dangerous. So that's why I need to be particularly careful when I make this bubble. And make it a little bit bigger. Okay, this should be big enough. Now let the bubble stabilize. Let's see what it does. Ooh, you see it makes a nice big sphere. This is because of the surface tension on the bubble. This is what water does in space, or all liquids by the way do in space. Let's see if we can deform this bubble a little bit or make it move. I have here a small plastic bag. No, the bubble stays perfectly round and it doesn't move. But what happens if I charge this plastic bag with also a positive charge by rubbing it on my clothes, for example? I will rub it really good, and now let's see what happens. See how I can move the bubble around. You see how it's really following the plastic bag to one side or to the other side and back to this side. This is because this bag is charged with positive electricity, and so when I come close to the water bubble, all the oxygen, which is negatively charged, tends to be attracted to it, and then it moves the water bubble to that side. If I go to the opposite side, it gets attracted to that side. So that was it for my small experiment, but you can do this also as well on Earth. Take a balloon, inflate it, rub it on your clothing, especially if you have something wool, for example. Let run a little bit water from the tap, and then if you get the balloon close to the tap, then you will see that the water gets deflected towards your balloon. It's exactly the same effect with running water on Earth, because of course these kind of bubbles you can't make there. Okay, that was it from on board of the International Space Station with our little water experiment. Science is fun. And of course, here on the International Space Station, science and space is also fun. Bye! Bye!